Hello and welcome to the first video on functions. So functions are things in maths that you've been working with all along. We've used that term kind of arbitrarily. Anything that relates y and x we've referred to as a function. Now we're going to really drill into it a little bit, and we're going to actually look at what a function is, which of the functions that we've called functions so far, which ones are actually functions and which ones are not functions, and why. And so over the 3 lessons, we're going to be looking at things like domain and range and mappings, which is this lesson. We'll also look at inverse functions, and we will look at composite functions. So there's a little bit of GCSE learning here, but there's also extending that up into A-level. So the first thing is to understand mappings. Now, a mapping is exactly what a function does. It takes one value and maps it to another value. And that's the equivalent of substituting an x value in to obtain a y value. So an x value in a traditional function maps to a y value. Now, only some of these mappings are actually functions. And we get into these terms one-to-one, many-to-one, one-to-many, many-to-many. And we find that actually the only ones that are functions are one-to-one and many-to-one. And we have to be mindful of that. And the way that we are mindful of that is if a function happens to be, or if an equation is defined as a mapping which is one-to-many or many-to-many, for example, and we'll get into these terms as we go through this, then we can restrict what's called the domain of the function. So let's just concentrate on these mappings first of all. So for each of these following functions, we have to do 3 things. We have to draw a mapping diagram. We have to state whether or not the function is one-to-one or many-to-one. And we're being asked to find what's called the range of the function. Now, don't worry if you're not familiar with what some of these terms mean. At this point, you will become familiar with them as we go through. So function A, we've got f of x equals 5x minus 3, and our domain is given as x equals 3, 4, 5, and 6. So what's the domain of a function? The domain of a function represents the x values. That's the simplest way that you can think of it. These are the values that will be substituted into the function, and only these values. So we are looking at 5x minus 3, but only for the values of x that are 3, 4, 5, 6. Every other x value is not included in this. So our domain represents the x values that we are going to substitute into our function. A mapping diagram, we use these 2 ovals, and all we do is we put in the left-hand oval the elements of the domain. And so we can see that from our question we have 3, 4, 5, and 6. And on the right-hand side, we have what's called the range. Now, if the domain is the x values that we substitute in, the range represents the y values that come out. So let's have a look. When we substitute 3 into the function 5x minus 3, what's the y value that we get? 5 times 3 minus 3, which is 12. So 3 maps directly across to the value 12. The domain is the x value that goes in. The range is the y value that comes out. Let's do the same thing for x equals 4. We'll substitute x equals 4 in. 5 times 4 minus 3 gives us 17. And again, we'll do the same thing for 5. We get 22, the same thing for 6, and we get 27. So let's just draw our arrows, because the mapping diagram doesn't mean anything without the arrows. So there's our mapping diagram. All of the elements of the domain 3, 4, 5, 6 that were given in the question have been mapped to the range, okay, the output of the function, the y value. And so that is our mapping diagram complete. Now we have to have a look at what type of function is this. And as you saw from the learning pack, we can have one-to-one, we can have many-to-one. Both of those are functions, but we could also have potentially one-to-many and many-to-many functions. I shouldn't say functions there. One-to-many or many-to-many mappings. Now what this means, what the one-to-one or many-to-one means, is for every element of the domain, describe how it maps to an element of the range. Now what we have in this function 5x minus 3 is that every element of the domain maps to one and only one element of the range. And that's what makes this a one-to-one function. So one-to-one means the domain, one value of the domain maps to one value of the range. Now if you're wondering what would a many-to-one look like, we'll get to that. But this particular one is one-to-one because one on the left maps to one on the right. So this is a one-to-one function. Part 3 is asking for the range. So when we are asked to describe the range of a function, you're best to write it in terms of describing f of x. And we can say that in this function, for the domain that we're given, f of x equals 12, 17, 22, and 27. So we've just made a list of all of the elements of the range. Now the other way that you'll see the range written is that y equals these. And between those two ways of writing the range, there's no right or wrong way. I just tend to say if the question's given as f of x, then I'll use f of x in the range. If it's given as y equals, I'll use y equals in the range. So just to recap, we have a function. We are told the function only exists for certain values of x. We created a mapping diagram to see what happens to those values of x when they're substituted into the function. We looked at the mapping diagram and observed that every one element of the domain maps to one and only one element of the range. And so we described the range as follows. So let's do the same for question B. This time we have a function g of x, and g of x is defined as x squared minus 3. And our domain is x equals minus 3, minus 2, minus 1, 0, 1, 2, 3. So let's go ahead and add those to our domain, the left-hand oval in our mapping diagram. Minus 3, minus 2, minus 1, 0, 1, 2, and 3. So those are all of our elements of the domain. So now to create the range, we're going to substitute values in and see what comes out. So if we take x squared, so minus 3, and substitute in, minus 3 squared is 9, 9 minus 3 is 6. Now you might see what's going to happen here, or you might not. That's okay. Substitute x equals minus 2 into the function, minus 2 squared is 4, 4 minus 3 is 1. Substitute x equals minus 1 into the function, minus 1 squared is 1, minus 3 is minus 2. Substitute x equals 0 into the function, 0 squared is 0, minus 3 is minus 3. Now something interesting happens. When we substitute 1 into the function, 1 squared is 1, minus 3 is minus 2. That's already there. 2, substitute into the function, 2 squared is 4, minus 3 is 1. It's already there. And 3 squared is 9, minus 3 is 6, and that one's already there. So we can see that the act of squaring here has meant that actually there are fewer elements in the domain than there are, there are fewer elements in the range than there are in the domain. So we'll go ahead and we'll put the arrows in to complete the mapping diagram. And we'll say that minus 3 there maps to 6, minus 2 maps to 1, Minus 1 maps to minus 2, and 0 maps to minus 3. Now, what else is going on? Well, when we substitute x equals 1 into the function, x equals 1 also mapped to minus 2. X equals 2 also mapped to y equals 1, and x equals 3 also mapped to y equals 6. So what we've got is a rather messy looking diagram here, because in this case, more than one element of the range, getting my ranges and domains confused, more than one element of the domain maps to the same element in the range. So when we describe this function, we're going to use the term many to 1, because many values of the domain map to one value in the range. Now this is still a function, because each element of the domain maps to one and only one element in range. So we'll go ahead and we'll describe the range of this function. And again, I will use g of x, because that's what's given in the question. And so I will now just list the elements that are in the range. So we have 6, 1, minus 2, and minus 3. So for our third question, we have h of x is 7 over 4 minus 3x. And our domain is given to us as x equals minus 1, 0, 1. So we'll go ahead and add those to our mapping diagram. And then we'll substitute those in one by one, and we'll work out what our range. So we substitute minus 1 in. Well, minus 3 times minus 1 is 3. So 4 plus 3 is 7. And 7 divided by 7 is 1. Substitute 0. 3 times 0 is 0. 4 minus 0 is 4. And so 0 maps to 7 over 4. Substitute 1. 4 minus 3 gives us 1. And 7 divided by 1 is 7. And so what we have here, as you can already see, is that each element of the domain maps to one and only one element in the range. And so our function this time, much like part A, is a one-to-one function. And so then we have to look at the range, and we'll say our range is h of x, and we list the values that we have. And we have 1, we have 7 over 4, and we have 7. So when we work with domains and ranges, it's all about doing that practice. And the next question, these three are a little bit more involved, and will involve you drawing a little sketch of the graph just to see what's going on. So let's have a look. We've got part A, we've got this graph, f of x equals 1 over x. Now I'm going to draw a little sketch of that, and that's going to help me tackle my domain and range. So here's my sketch, my x-axis, my y-axis, and you have to forgive the sketch somewhat, but for the graph of y equals 1 over x, I know that it looks like this. Let's try that sketch again. Looks like this, and it looks like this. Okay, so that's generally the function 1 over x. Now, we have to look at this graph and work out, we've been asked to write down the domain of the function and the range of the function. And we can see that with 1 over x, there's a very clear asymptote where x equals 0, because we can't divide by 0, our answer is undefined. So when we're actually writing down what the domain of this function is, what we need to consider is which values of x will work for this function and which values will not work for this function. So for this one, you can see that if I substitute any negative number in, I will get a y value out. if I substitute any positive number in, I will get a y value out. The only value that will not work for this function is x equals 0. And so if we were to write the domain for this, we must list the fact that x cannot be 0. So our domain will be x not equal to 0. And then we're going to add in this extra bit. So we've got x and what looks like a capital E that stands for a set. And then this r, this double struck r, which stands for the real numbers. So the domain here is that x is not equal to 0, but x is a real number. Okay. So we're restricting the domain. Okay. This actually turns this function into a one-to-one function because we've restricted the domain to not include x equals 0. Now, if we're asked to consider the range of this function, again, we go to the graph and we say, well, what values of y will we get out? This is literally just describing the y values that we will get if we substitute any of our x values from the domain into the function. Now, again, you can see that the behavior of the graph is that as we increase x to infinity, it gets closer and closer and closer to the x-axis, but it will never cross it. And then as we get closer to negative infinity, you'll observe the same thing. There is one y value that will never happen in this graph. And again, it's 0. And so we're going to describe the range as this. We've got f of x is not equal to 0. That's our range. So again, just to recap, the domain is where we describe what x values will work, and the range is what y values are generated by those x values. So we'll have a look at this second graph. And again, we'll start by drawing some axes. And we'll just have a look at the graph. And this is where the graphs really come into their own. We need to consider what the graph looks like in order to help us. So this graph of 1 over x minus 3 is a transformation of this original graph. And hopefully you've got the understanding still that what happened here is that the graph has shifted to the right by 3. Now what that means is the asymptote is no longer at x equals 0, it's moved along. So here's my curve, like this. So we've got here this coordinate 3, 0, and there's my asymptote. That's my curve, f of x is 1 over x minus 3. So again, we're being asked to write down the domain, and by domain, we're talking about which values of x will make this function work. And so every x value other than 3 will make this work. So x is not equal to 3, but x is a real number. And again, we're not asked to write this, but it's worth just having a look at it, that this is a one-to-one function. So the range is going to be very similar to the previous function. The range here is still going to be just that f of x is not equal to 0. Every other y value will come out, but you will never get y equals 0. So again, consider the graph. What values of x will work for the function? That's your domain. And your range is the y values that are generated by that. So for part C, we have the function f of x equals e to the x plus 2. Again, let's just draw a sketch and have a look at what this is looking like. So we've got our x, we've got our y, and e to the x plus 2. Now e to the x, exponential graph. So e to the x plus 2 is just the graph of e to the x moved up by 2. So I'm going to draw this horizontal asymptote here, and I'll get to sketching the graph. So here we have our e to the x plus 2. That's what it looks like, our exponential function. We know that it goes through the y-axis at 3, and we know that it never reaches this horizontal asymptote. So let's get to defining the domain and the range. So the domain, remember, is where we describe any of the x values that can be substituted in that will generate a y value according to the rules for functions. And I can just see that for this domain, any real number of x will work. And when I say a real number, I mean it just can't be a complex number. So any real number will work, and that's how we list it. We just say x is a member of the set of real numbers. This is also a one-to-one function. Now the range for this, we'll have a look at the graph. What y values can we possibly get from this function? Well, we know that we've taken the original graph of e to the x and we've translated it up by 2. And so this horizontal asymptote has the equation y equals 2. So that means that the range of f of x can be described as f of x is greater than 2. Every y value that you get from this function will have to be greater than 2 because this is the asymptote that it approaches as we get towards negative infinity, but it never crosses. So that's a quick tour through domains and ranges, and we'll have this entire lesson to work through problems to do with domains, ranges, and mappings, and you can ask any questions in the lesson. Okay, thank you.